Hey everyone, welcome back to another episode of Cool Electronics Guy, where the electronics are cool, but the guy, not so much. So let's start by jumping right into our beer of the day. As you can see, today's beer of the day is Beer Monkey, is what it's called. It's a fruited sour triple, which is just another way of saying a strong pale ale. But it really wasn't super strong to me compared to other pale ales. But it weighs in at 9.5% alcohol. And it's made by the Victory Brewing Company, and that is out of Downingtown, Pennsylvania. So if anyone in Downingtown is watching, I just want to say thanks for some awesome beer. I think that this beer was really nice, a very well-rounded beer. The balance between the raspberry flavor, the hops, the alcohol flavor, it was fantastic. It's really a very simple beer, but the sophistication is really in the balance of the flavors. I think it's probably difficult to make a beer like this. I mean, sure, we get strong, amazing beer flavors in other craft beers that are outstanding, but this one is just different. It's not about strong, robust flavors, but it's about the subtleties in flavor. I give this one a 9.5. It's fantastic. Really amazing beer. Really loved it. So please check it out. Today's project is the fifth in the Arduino Starter Kit projects, and it is called Mood Q. This project will involve mapping values, servo motors, and the built-in Arduino libraries. And Arduino classifies this as a level 2 project, and just like all the other ones, it builds on all the previous projects. What a surprise. Some of the components that we're going to be using are one potentiometer. Most people call it a pot. It's really just an adjustable resistor. We're going to use one servo motor, one motor arm, two microfarad capacitors, and again, sometimes people call them caps. We're going to use one 3-pin male header and several jumper wires to connect. While we're wiring this up, I just want to say a few things about the components that we're using. There's a servo motor in this project, and for your information, servo motors don't spin in a circle like you would think. They move to a specific position and don't move again until you really tell them to. They usually don't rotate more than 180 degrees. Much like the way we use the pulse width modulation in the last project, servo motors get a number of pulses that tell them what angle to move to. The pulse always comes at the same interval, but the width changes between 1,000 and 2,000 microseconds. Excuse me. Also, being that the servo only turns 180 degrees and the analog input only ranges from 0 to 1023, we're going to have to use a function called map to change the scale of the values coming from the potentiometer. Make sure you check out the Arduino libraries too. When we write the code for this project later on, we're going to use the libraries designated to be used with the servo motors. Libraries are great. They save so much time without having to reinvent the wheel. Let me talk a little bit about the wiring up process that we're doing right now. The first thing we did was wire up the 5-volt and ground to one side of the breadboard from the Arduino. Next, we placed a potentiometer on the board. You can see that it's the blue base with the knob is white. We're going to connect one side to 5 volts and the other to ground. The middle pin is the wiper, if you didn't know. It gets connected to analog pin 0. This will control the position of the servo motor. There's 3 wires in the servo motor. Red's power, black is ground, and white is the wire that will receive the information from our Arduino. We're going to plug a 3 male header into the female ends of the servo wire, then connect the headers to the breadboard so that each pin is in a different row. Connect 5 volts to red, ground to black, and white to pin 9. As the servo begins to move, it'll draw more current than if it were already in motion. This will cause a dip in the voltage, obviously. But so what we're going to do, if we place a 100 microfarad capacitor across power and ground near the male headers, we can smooth out the voltage change. We're also going to do the same with the 100 microfarad capacitor across power and ground at the potentiometer. And you know, always be careful when you're using a capacitor. The side of the capacitor with the black stripe down its side, that's the cathode. That goes to ground. The other leg is the anode, and you guessed it, it goes to power. When we use capacitors like this, they're called decoupling capacitors. They'll reduce changes caused by components from the rest of the circuit. It's really important to place the capacitors correctly, because if you, like I said, if you reverse the anode and the cathode, the capacitor could explode. And we don't want that. We don't want to get hurt. We don't want to mess, and we don't want to ruin our board or our project. So we're going to wire this up, and then we'll start coding in a few minutes. Alright, now that we have everything all wired up, it's time to start coding. The Arduino project book has detailed instructions on coding all the projects in the starter kit. So I'm not going to go over every little detail, because you can do that yourself if you buy the starter kit, which I highly recommend doing. It's a great learning experience. But I'm going to tell you the steps that need to be followed while programming this project. First, you're going to need to import the Arduino library for this one, which we've already done that some time ago. Next, you'll create the servo object, then declare your variables. Then you need to associate the servo object with the Arduino pin and initialize the serial port. Next, we'll need to be able to read the analog input and print out the value from the potentiometer to the serial monitor, which we've used in the past couple of projects. Then we'll map the potentiometer values to the servo values. And finally, we'll get to rotate the servo motor. But don't forget to put a delay in at the end of the loop, so the servo has time to move to a new position. Once we get this programming done, then we'll operate it. Alright, once you've completed the programming, open the serial port, and you'll be able to see the values. Let me see if I can get that serial port on there. There we are. Let me zoom in. See if I can. There we go. If you turn the potentiometer, you'll see the values change on the servo, and the servo motor turn to a new position. So we're going to go ahead and turn the potentiometer. Watch the values change on the screen. We see the angle. Turn it just all the way to one direction. Turn it the other way, slowly. And there it goes to 0. Now slowly, see the numbers climb as we turn it. And I'm going to try and zoom in on the servo motor now. And you can see, as we turn the potentiometer, you can see the servo motor is turning. Also, the project book shows a cool overlay you can make to customize this project for your own needs. You can be creative and have fun with it. Let me see that book over there. Alright, here is a picture of what they have in the Arduino project book. You can make that arrow and that overlay to go over the project. Again, you can be creative. You can label it to whatever you want it to say. We're going to play around with this for a little while and finish our beer. I hope you enjoyed this project as much as we did. This week's video will be the 6th project in the Arduino Starter Kit. It's called Light Theremin. It'll utilize a phototransistor and a piezo element. Some people say piezo, some people say piezo. I've heard both. I don't know how it's supposed to be said, but whatever you prefer, piezo or piezo. It's listed as a level 4 project. It builds on all the other previous projects that we've done. And if you don't know what a theremin is, It's an electronic musical instrument. It's controlled without physically touching it. So that'll be a pretty cool project. We're gonna make some music next time. Please feel free to leave comments below. We'd love it if you'd subscribe to our channel. And don't forget to like our video and be sure to ring the bell. Everyone at Kool Electronics Guy wishes you a happy Easter. Don't eat too much candy. Have a good one. Thanks for watching. We'll see you next time.